So as a follow-up to my video on the metal additive manufacturing workflow, this is another video I'm making for the plastic workflow. Again, here under one roof we have all the software, hardware, the materials which will allow you to build a complete workflow without needing to go to any other company or manufacturer. So at the start, here we have Geomagic Design X, which is a reverse engineering software which you can take a part that you have, scan it, and come up with a complete parametric CAD model. That you can then get it ready for additive manufacturing. So here's a scanner, and that gives you a 3D model. Then using that you can go to 3D Sprint, which is another software which it lets you orient your parts properly on the build platform, perform some operations, basically get it ready for 3D printing. This is the preparation stage. From here you move to prototyping. So this is one of our plastic 3D printers. This is a figure 4 standalone, wherein you can print prototypes of the parts that you want to get into production. So this is one of the parts that's being printed. It's impossible to make a injection mold tool for this, but it can be printed using our printer. Now the key here is that yes, of course you can print, but then it takes a long time. Normally 3D printing is not good for high volume production, or that was the case. But as you can see now, once you're ready with your product, with your prototype, you then move to the figure 4 modular. This is basically comprised of a controller which controls multiple cells or modules. And just to give you an idea, if you look at the numbers here, 90 parts, a total of 45 pairs, was printed in 5 hours, 5.5 hours. So this gives you the idea of scale that can be achieved using our flexible manufacturing systems for plastic. Now there's a third version of the figure 4. It's called the figure 4 production, which is not on display here because that is basically more of a configurable solution. There are 4 print engines per cell, and it is insanely customizable because that's where you have robotic arms that come in and pick and place, take platforms out, drop them inside. So the difference between the modular and the standalone is here the material, the filling, everything is manual because you are in the prototyping stage. You want to change materials, do all kinds of stuff. But in the modular, the material filling is all automated. So this gives you the scale that you need to get to short run productions. But when you want to get to real large scale mass manufacturing, something like 1 million parts a year, then you need to move to figure 4 production. So what we're trying to show here is that under one roof you have a complete solution which includes the software, the hardware for prototyping, the hardware for short run production, and then also we have the entire system for large scale production. And here's a bunch of parts, which is the final output. This is like impossible to break. It's hard to break. This is a perfectly. This has got the finish, the strength, the durability of a plastic injection molded part, and this is going to be a game changer. Now, this is the material here is called the Pro Black 10. It's a new material. The problem with resins is that they age over time and they are and their part properties disintegrate. This has been tested for 7 years length, indoors and outdoors, and it has really stood the test of time. So what we're trying to show here is that under one umbrella you have a complete end-to-end plastic additive manufacturing workflow, which can guide you from design to preparation, to prototyping, to production, to post-processing, inspection, and also management. The piece of the puzzle is a software called 3D Connect. Not sure the video is running, but yes, this is a proactive support system wherein our machines are linked to the cloud. We can do remote diagnostics. We don't see the parts that are printed, but we see the readings from all the sensors. We understand when something is going out of spec, and then even before your machine goes down or something goes wrong, we can ship the parts to your facility and have engineers come and look into the problem before it actually happens. So we understand that in the prototyping stage, it's okay if there's some downtime, because you can either get the parts built outside or maybe it's a day or two delay. But when it comes to production, no, uptime is key. So we have all this within a single organization, and it is completely configurable to your needs, and this is a complete end-to-end workflow.